Hello everyone, my name is Valentin Malik. I'll present our joint work with Ivan Sedykh, Dmitry Blukhanov, Nikita Sorokin, and Sergey Nikolenko. It's called Searching by Code, a new SearchBySnippet dataset and SnippeR retrieval model for searching by code snippets. Let us discuss what we have today on our work. So the key contributions are novel search task, code search task. I'll describe it in detail later. Novel dataset and novel model. I will describe all of that in the specified time. So first of all, the task description. I think everyone knows the classic code search task when we have a docstring and we would trying to find a function body which is actually related to this docstring. So it is created similarly to code search net, which is I think one of the classical datasets in this task. So we have a set of functions with docstrings, and we separate docstrings from function bodies, and we use docstrings to find function bodies. This is classical design. Another thing that is also could be related to our task is so-called clone detection. When we have several code snippets, we have a query code snippet and a code snippet which is a response, a relevant document. So we have how we can extract this. We have function body, and this function body is known to be the same, I mean, to do the same as function body in some other dataset, in some other code. And knowing this, we can create a code clone task. So we're trying to find clones. That means the code which makes the same, although looking different. And our task, which we call search by snippet, is a bit different. Actually, I will show that it's not only looking different, it's actually different inside, since the existing models are performing relatively bad on this dataset. So what we have? We have code snippet, for example, the one shown below, and we have some textual description. For this specific task, we're using the textual instructions which could be found online on some community services like Stack Overflow. But for the sake of simplicity, for now, we will say that textual description is the docstring. So our search by snippet task, in a way, close to classic code search task, but in the other direction. So we're searching docstring by function body. It's actually not really there, but it is how it's actually working. Okay, so this is the task we are presenting. We have code snippet and we find in textual description. Let us go for the data. What I'm talking about actually. This is an interesting idea because why we actually need this new task. The new task I'm talking about is needed when you're, for example, coding. For example, when I'm coding, I'm searching some problems in my Python code, for example, some exceptions and so on, in the web browser, I mean, in some web search engine. And the web search engine relatively often points me to this community question answering services, for example, this Stack Overflow, as you can see. So I have a code snippet of myself. This is actually code snippet and traceback mostly. And this code snippet and traceback I'm using to find some question where a person has the same issue as me. So there should be maybe or should be some code, maybe some actual error description, and maybe, but it's not for sure, some text. There must be only the text there, but this is the actual difficulty of this task. So we don't know how the actual issue is described, the issue which is really relevant to the issue we have as a programmer. So regarding the data, so you see the Stack Overflow screenshot to the right, and this is the data we have been working with. So there are 2 million question answer pairs for Python related questions, and these Python related questions, they actually contain several things. This is the questions themselves. We use this question description to actually work with that. The answers to the questions, and what is really important, we have this green mark in the center bottom. you see that green mark for Stack Overflow, it shows that this answer has been accepted. So we know for sure, but maybe with some, maybe it's not like 100%, but for a person who asked, it's helped. So this is, we know this is a good answer for sure. And there is some other metadata as these green marks. And more importantly, there are some other metadata. I'll describe it right now. So maybe you know, maybe you don't know, but Stack Overflow, when you're working with it, when you're trying to ask a new question regarding your issue, it will make a search right while you're typing your question. And if your question is describing the same issue, which it has been actually the same to you by the word. So if it's actually related by the words which are really close to the ones you use. So it shows you the list of such possible duplicates, and it's strictly prohibited to create a duplicate question. So when we're creating a new question, which is not closed and not deleted, we know that it is a unique question. But there are some moderators which are actually looking through all the new questions, and if they know the issue which has been described differently, but is the same by human judgment, this is important. And if we know that this is by human judgment the same issue, they could link it to this question. They say that this is a duplicate question, but they do not delete this new question. They just link it. And we use this metadata, this linkage, to actually get the so-called duplicate questions. Why do we need them? Because these questions are actually what we want to use, what we want to have. Because when I'm, as a person, I'm typing my code and I see some issue with it, I'm trying to look it for on the website, I mean on the web search engine, I am formulating my problem pretty differently. And fully duplicate questions are as much close to this case as possible. So these full duplicate, as we call them, questions are what we actually want to do, want to actually search for. But there are only a few full duplicate questions. I'll describe what the full duplicate now, so it will be more understandable. Full duplicate, we call it when there is a linked question to the specified one, and it has accepted answer with this green mark. So this is really important. When we have these full duplicate questions, we can say that they for sure has good answer and at least two formulations of the same issue. And we use them for testing. Why for testing? Because there are only a few such pairs, only a few hundreds actually, in 2 million question answer dataset. Okay, so how it actually look like, the dataset we have? The dataset we have looks like something like that. We have, for train set, we have code and traceback extracted, and we have some answer, some post title, which has been actually posted in the online, I mean on the Stack Overflow, and we have this whole post with whole text, and we have best answer, which is the answer we want to get, and we have query, which is code snippet and answer, traceback specifically. So code snippet and traceback, this is our query, and the textual description is our document we are looking at. The dataset we have, this is after the cleaning, it's only 900,000 questions, of course, with some answers and some metadata, and only 500 questions in test set. Why 500? As I described, this is full duplicate questions. This is the questions which has duplicate question with answer, and we have only 500 of them to test. Okay, so as you can conclude, there is specifically domain shift. So we need some tricks to train efficiently a model on this dataset. So what about the model I'm saying about? The model has three specific features. This is single encoder retriever. So single encoder, because we use the same encoder for query and for search. So we use the same encoder to encode a query, and the same encoder to encode index, which can be stored. So we store the vectors from the encoder to search efficiently. And we use our encoder to get the vector and compare this vector with the dot product, and we get the answer. In the right top, you see the loss description. So we use this noise contrastive loss for efficiently train our model. How we train it? We train it using hard negative mining and use self-training. Let me describe it a bit later. And what I need to say, the last feature which is important, but that we base on the pre-trained language model, which is in our case the best was GraphCodeBERT, and this GraphCodeBERT model has been shown huge improvement over others. So what about the negative and hard negative? We use so-called hard negatives to train our model as it's shown for the loss function. But what is important, how we actually get these hard negatives. This is interesting because let us start with a small description of information retrieval task. In information retrieval, we have document set, we have query, and in this case, query is reddresses, and documents are images. This is just for simplicity, of course, because we're working with textual documents, but for visualability, I use these images. So we're rank this document set, and the first image of reddress is the best document for reddresses, obviously. But we need to describe what is actually going on here. So what we have? We have reddress, which is relevant document, and we call this positive document. All other documents are negative documents. So negatives, that means they are not relevant. And in our case, it's okay. But what about hard negative? Hard negative is when we have some trained model and we have some ordering for the document set. For example, like this, yeah, red dress, blue jeans, and black short. So this is actually interesting. If, for example, we have not blue jeans, but red jeans, then it would be harder for our model to actually choose from two red objects, which is the best described by red dresses. And we call these hard examples, hard negatives. So these negatives are getting from this trained model, and they're not true relevant documents, but they're hard to choose from. So how it's actually, where we get these hard negatives? We get them from not any trained model, but from our model. So firstly, we just initialize our model somehow, for example, randomly. We train it on the database of our hosts we have retrieved, and we know the relevant documents from the database. We filter the documents and filter the documents which are really relevant, and other top ranked by our model documents we use as hard negatives to train our next model. So we use our model again to train it on this new data set with hard negatives and positives. And this is training more effective than the existing training without hard negatives. So we train with hard negatives with our contrastive estimation loss, and this allows our model to perform better. How better? As we can see, if we get the just GraphCodeBERT as it is, it shows really small results. If we get CodeBERT, SynCodeBERT, they're not really good also. If we train GraphCodeBERT on the classic CodeSearch.net dataset, so it will be able to retrieve docstring by function body, it is still not really effective, because BM25, the model which has no training at all, it just works, just initialized and works, we can see that it's better than all other models, except, of course, our model, which we call SnippeR. This SnippeR model, which I have been described to you before, is trained with hard negative samples with self-training. It shows that it outperforms SnippeR, and of course, the result could be furtherly improved if we use more self-training or better models, but it is still better than BM25. So regarding the conclusion, we presented the novel task, which is we suggest to community to work with. I think it's a really interesting task, and it's different from the existing ones, as shown by the existing models, which are not able to solve it. And even with our model, it's not really solved. It's only in the beginning. We present new significantly different data set, which hasn't been presented yet, and we present novel model which is effective for this task. Of course, it's not like solving the task yet, but it's still effective. And what I'd like to mention that DN25 is still the best for search. This is a really hard baseline, and I personally recommend it to use first for any retrieval task. If you want to contact with me, please use the QR code to the bottom left, sorry, and I will be happy to answer your questions. Thank you.